Alrighty, so in this video we're going to do part 1 of question number 3 on page number 3, and then I'm going to have a second video that is going to go along on the second part of question number 3 on page 4, that is part of exam 3 in relation to finding derivatives and critical points and graphing those. So what do we have over here? So we have here the f of x function, which is f of x equals x to the power 4 minus 6x squared plus 8x minus 3. So all of that, if we were to simplify it, equals to 3 plus x times x minus 1 to the power 3. And then right here we have another useful expression right over here, which is 4 times x plus 2 times x minus 1 squared, which equals to 4x to the power 3 minus 12x plus 8. So these are going to be helpful later on, but we want to focus on the f of x function right here. So for the first part of our problem, we're asked to find the first derivative and the second derivatives of the problem themselves, or of the f of x itself. So typically in these kinds of problems, especially when it comes to graphing, so the first derivative, f of x, represents velocity, and then second derivative, f of x, pertains to acceleration. Specifically, velocity refers to slope in this case, and then acceleration refers to concavity. The concavity of the graph. So first derivative of f of x. So how do we find that? So we have here x to the power 4 minus 6x squared plus 8x minus 3. So we want to take it turn by turn. So the derivative of x to the power 4, that would just be 4x to the power 3, because we're using the power rule in order to find the derivative. And then the derivative of 6x squared, that would just be 12x in this case. And then the derivative of 8x would just be 8. And then the derivative of negative 3 would just be 0, because the derivative of a constant is always 0. So we have the first derivative right here. Now it's time to find the second derivative. So to find the second derivative, we're going to use the first derivative that we got here in order to find the second derivative. So write it in the derivative notation. So we have the double prime of f of x in this case. So we have 4x to the power 3, which in this case would just equal 12x squared. And then the derivative of 12x is just 12 in this case. And then the derivative of 8 is just 0, because the derivative of any constant is always going to be 0, like I said before. So as we looked earlier at the problem, we have these expressions right here that were simplified before. So these expressions pertain to this one. So right here, this one can be simplified down to 4 times 3 plus x times x minus 1 cubed. And then this one can be simplified to, this one simplifies to that one over there. My apologies. So it'd just be one of them that simplifies that we're already given in the problem. So it'd just be 4 times x plus 2 times x minus 1 squared in this case. So it's going to be useful later on, like when we're trying to find any critical points or anything like that. So critical points. In the case of the critical points of f of x, we want to take the first derivative that we have instead of equal to 0 in order to solve for x. So in this case, we have the first derivative of f of x, which equals 4x cubed minus 12x plus 8, which simplifies then to 4 times x plus 2 times x minus 1 squared, which we then set equal to 0. So we set both of these terms right here equal to 0, which in turn we'd have x plus 2 equals 0 and x minus 1 equals to 0. So in this case, x equals -2 and x equals 1 right here. So these are going to be our two critical points, but that are going to be on the graph. So these points occur when the y value is equal to 0 in this case. So as we're going to graph it later on, we want to make sure that we have the y coordinates of these in this case. So we want to plug those into the f of x in this case. So if we plug this in, if we plug -2, so we have f of -2 equals 4 times -2 plus 2 times -2 minus 1 squared, which then equals to 4 times 0 times -3, which in this case would just be 0. And then it would be the same thing for 1 as well too, because you'd have 1 minus 1 over here to the square root of to the power of 2, which would just be 0 in this case, and then 0 times anything just equals 0. So like just to prove that like these two are indeed the critical points that we're looking for in this case. So now that we have these two critical points, we want to put them on the number graph, on the sign chart, in order to determine whether or not f of x has increasing or decreasing intervals. So in this case, we're going to do a sign chart, just like that. And then here we're going to do -2. Here we're going to do 1. So now we want to take different points and test them out. So in this case, we can take a point from -infinity to -2 in order to plug into the f of x in order to test it out. So in this case, we can take something that's going to be simpler. So we can take f of -3 in this case. So if we plug -3 into here, into the f of x, right here, we would have so 3 times 3 minus 3 is just 0, and then 3 minus 1 is just -4 to the power of 3, which would just be negative in that case. So in this case, we'd have a negative over here, and then what else we would have? So we can take a point from between -2 and 1. So we can take f of 0, for instance. So if we take that, we would have and plug it into the f of x, or into f prime of x, I should say. If we plug it into here, so we plug 0 plus 2 is 2, and then 0 minus 1 is -1, but that to the power of 2 is just positive, so this would just be positive in this case. So this would be negative, this would be positive, and then now we can take this and find a number that is within this interval. So we can do f of 2, for instance, just to make it simpler for us. So if we plug f of 2, or f prime of 2, I should say in this case, we plug that into this, so we have 2 plus 2 equals 4, and 2 minus 1 is just 1, to the power of 2 is just 1, so this would also be positive as well too. So what does that mean? So if we have a negative and a positive over here, this means that at critical point -2, we have a minimum set of x coordinates, because this is the lowest value that it can go to in terms of x, and y. So it's going to go the lowest because it first decreases and then the slope increases. So that indicates a minimum. But if it were the other way around, if you had a positive first, you know, if it were increasing first and then you had a negative, that would just be a max instead. And then if we have a positive and a positive, that would neither be a max or a min, it would just be neither, but it would mean that there would be a saddle over here, because when you have two intervals that have the same sign that are right next to each other back to back, have two negatives or two positives, it's always going to be a saddle. So this, even though it's neither a max or a min, it's going to be a saddle in this case, because the slope increases, but then the slope increases again, creating a kind of a saddle kind of shape in this case. So now that we have those figured out, we want to write down the intervals that we found. So in this case, increasing increasing is negative infinity. Oh, sorry, increasing is not negative infinity, it's decreasing. So increasing would be -2 to 1 union 1 to positive infinity in this case. And then decreasing over here would be just negative infinity to -2 in this case. So these would be the intervals that we have. And now using those critical points that we have, we want to plug them into the f prime of x in order to find the y coordinates that we need. So in this case, what we can do is just plug in f of -2 equals 4 times -2 plus 2 . Yep, and then that times no, that doesn't make any sense, because you still have the critical points, because it would just be 0 in that case. So what we want to do is actually plug it, instead of plugging it into the f prime of x, we want to plug it into the f of x. So what we want to do is plug it in. So f of -2 would just equal 3 minus 2 in this case, or 3 plus -2 would just be the same thing, times -2 minus 1 to the power of 3, which would just equal, we'd have you just have +1 times -3 cubed, which would just give you -27. So that would be the the y coordinates. So in this case, the minimum would be on the graph would be at -2, comma 27. And then now we want to find the f of 1 in this case, which would just be 3 plus 1 times 1 minus 1 to the power of 3. So in this case, it'd just be 4 times 0 to the power of 3, which would just be 0 in turn. So this point would just be 1 comma 0 right here. So that's where the location of the occurrence of the saddle would be. So lastly, what we want to find is inflection points. So inflection points, how you find those inflection points is just by taking this, the second derivative, and setting it equal to 0. So what we want to do is f double prime of x equals 12x squared minus 12 equals to 0. So now what we can do is we can rewrite this first off. So we can rewrite this as 12 times x squared minus 1, in this case equal to 0. And then what we can do is just we can apply the we can either apply the quadratic formula in this case, or we can just simplify it even further, simplify this even further. So we can just have 12 and then x plus 1 times x minus 1 in this case. So so if you, let's just double check just in case if it's equal. So we have x squared, then you have negative x, and then positive x, so that will just cancel out, and then you just have the negative 1. So yeah, this is perfect right here. So we can just set this equal to 0. So in this case, we can just have x plus 1 equal to 0, which x equals negative 1, and then x minus 1 equal to 0, and in this case x equals 1. So these are going to be the inflection points that we're going to have. So to make sure that we can properly put them on the graph, we want to make sure we plug those into the f of x in order to acquire the y coordinates. So plugging those in, so we'd have f of negative 1 equals 3 minus 1 times minus 1 cubed, which then equals to 2 times negative 2 cubed, which then equals to 2 times negative 8, which in this case equals negative 16. So this coordinate right here would just be negative 1, 16, bam, just like that. And then we want to do f of 1, which then equals 3 minus 1, or sorry, I should say 3 plus 1, and then 1 minus 0 to the power 3, which then just equals 4 times 1, which then equals just 4. So in this case, the point here would be 1, comma 4 in this case. So these two are going to represent the inflection points, and then these 2 points are going to be, so this is going to represent the min, and then this is going to represent the saddle on the graph. So this is part 1 of page number 3, question number 3. Thank you.